Let's see, the actual talk is completely printed out here on a 10-page handout here. It's called Tuning Apple II Floppy Drives. And also the entire text file of the paper handout is on the back side of this disk, docs for track center alignment testing. And the front side is the software that's used for doing this alignment adjustment. The software is called AppTest. It's very old software. Nothing new at all about it. I think it's dated 1983, but it works, and you can turn a non-working floppy drive into one that works perfectly, because this is often a big failure with 5-inch floppy drives, especially as they get old, I think. And you don't need any technical tools or supplies, not even a multimeter. But all you need is this disk and a couple of other disks to use for comparison, and a Phillips screwdriver, and that's really about it. Now, I gave a different talk 2 days ago on Thursday, which was just a set of unrelated topics. And one of them I completely forgot to cover. And not only did I forget to cover it, but I forgot to bring the computer that it was about. The name of this one was called the Stealth 2GS. And I packed in a hurry. I didn't have my list of topics with me, and I simply forgot to put it into the car. I had written this up in an article in Juice GS magazine years ago, Hacksaw Hacking, the Stealth GS. And the reason I call it the Stealth GS is kind of like a GS hidden inside of a 2E case. And I don't know if this applies to many others. I suspect it does. But my wife thinks I have too many apples. And from time to time, she counts them. And she'll probably count what's in the garage after I get home, too. Because she knows that if a new computer's coming in, it's being snuck in at night. But I call this the Stealth GS because since it looks like a traditional 2E, somebody who's counting them is not going to even notice that another computer has come into the house. Now, I think everybody here knows that Apple put out a 2E conversion kit for the GS, I believe right from the first year that they had the GS, wasn't it? Around 86. It was a metal bottom plate with the 2GS motherboard in it, and all of the standoffs were in the correct position. The back panel was nicely made, so it was just a matter of bolting it in, and there you'd have a GS in a 2D case. The ones that I made, and I made about 5 of them, the one that I was going to bring but forgot it at home is the last one that I have. I didn't get that kit. In fact, I've never had that kit that Apple made. I took a standard 2E, I think the middle version, the kind with the black keys on the, or black lettering on the tan keys. And I took the motherboard out, and I kind of got it into the case of the 2E by making custom modifications. One of the modifications was real hacksaw hacking of the back panel. And let's see, I mean, this is a coincidence that I have to bring this computer, but this one was destined to also become a Stealth GS because, I don't know if you can see it, but there is some marker lines on this back panel. That was where I was going to cut it out. Because, in other words, like the openings on the 2E are not in the right position for the 2GS board. So the idea is you have to take a hacksaw and cut this out. I do remember I probably broke a dozen hacksaw blades doing it because this back panel is so tough. But anyway, it did work. The other big thing of doing the Stealth GS is that the motherboard has to stand off from the bottom plate. This is true with every computer because you have all those little solder points in the bottom of the motherboard. If any of those hit a metal plate, there's going to be short circuits galore. With the factory-made computers, they use nylon standoffs that go through holes in the metal board into corresponding holes on the motherboard. The 2E, and I'm sure even the 2 Plus and the original 2 have the same kind of thing. The problem is that to take a 2E motherboard, put it into the probably take a 2GS motherboard, put it into 2E casing, none of those standoffs are in the right position. But you can't really bore holes through the bottom of the motherboard because you're gonna break a lot of circuits and nothing is gonna work. Even if you did it just once, I think you'd end up with a piece of non-working junk. What I did to protect the motherboard from the short circuits and lift it off the bottom is I cut 3 strips of wood, the right length. I think they went horizontally like this. I cut them the right length. They were about 1 inch thick, and I used strong adhesive. I think I first glued it to the metal plate on the bottom. I used some adhesive called liquid nails, an odd name for it, but it really holds strong. So I glued it onto the bottom metal plate, let that dry, and then the motherboard was glued. I can't remember if I used liquid nails on the motherboard itself. Does anybody know? Is that a conductive type of adhesive? Anyway, whatever I used, it was something that didn't conduct electricity because that too would spoil all the circuitry. So I glued that motherboard onto the wooden strips, which kept it off of the metal bottom plate, and it works. The only defect in my homemade Stealth GS is that the sound is a little bit scratchy. I'm not sure if it's the amplifier or anything else. It's still very understandable, but it's just a little scratchier than in a stock computer, but it does work.
Just wondering, I have the same problem with the coloring of the letters on a 2GS monitor. I think I was running ProDOS because I was just using it as a bigger 2C because I had bigger files. But I got that
That
purple,
shadowing.
green, and white lettering. What causes that?
Darn if I know. What he's talking about, the appearance of those colors up on the screen. Mostly with 2E here, I just use monochrome green monitor. It comes out real sharp. Does anybody have any idea what causes this color distortion? It's especially noticeable with text like this, but it's less noticeable if you have graphics.
Right, but graphics really can't.
The 3 tubes in the monitor are slightly out.
In the, oh, you mean the 3 electron guns for the colors?
Mean the RGB?
Well, I don't know. It seems to show up more in some situations than in others.
Yeah, text on a
I mean,
colors.
the GS. I mean, we've seen the color graphics from this projector, and they're excellent with other computers and other software.
Oh, yeah.
Okay. So anyway, that's a Stealth GS. I haven't made any more of them. But I called the article "Hacksaw Hacking" because hacksaws were definitely used and hacksaw blades were broken. Okay, now the main topic of my presentation, and for those just came in, I have it fully written up in a 10-page handout, and there are discs here. And there's actually plenty of these for everybody if you want them. I think I have about 25 printed copies, maybe 30 discs here. Okay, the main topic is disk alignment using software. And the software that I'm using is AppTest. But first, though, I think that I'll explain about this one. This is not actually AppTest. This is Data Life Disk Drive Analyzer. You can see it also goes back to 1983. I kind of like this one because it does 4 separate tests on the floppy drive. And I've sold a bunch of floppy drives on eBay in the last 2 years. I've got 50 more of them on the shelf in my garage. My wife says, get rid of those things. But it is nice to be able to take pictures of the screens on here and show that it's passed these tests. Like, let me do test 5. Whoops. Oh, it's testing on the 5.25 drive right now. Radial alignment, which is the topic of my presentation, disk speed, clamping. The other thing about clamping, if it's out of adjustment on clamping, I don't know how to readjust it.
Testing the drive
anyway,
itself, right?
It does write write and read also. Now that was where it did all 4 of them in a sequence. If you do them individually, you have this nice graphic here for radial alignment. Watch that, you can see the head go back and forth looking for the center of the track, and it says this one is properly aligned, this one here. Let's see, let me go back to the menu. Now do disk speed. This probably has the same color distortion as that text screen, but it's less noticeable with big graphics like this. Okay. Okay, it says speed is good. Okay. And then clamping. I think clamping means when that what the spindle goes down from the top to hold the disc. Is there any wobble in it? But all I can think of is that maybe some little clip on that top part might come off, and that might cause a clamping error. And then write and read. Oops. Oh, there it shows data, those little specks going in, writing, now reading. Okay, it says pass. So it's a pretty little graphic, and when I've shipped out these disk drives, I'll always include a copy of this disk, because then they can go through it and be impressed by the graphic. The problem, though, with this type of evaluation, it just gives yes and no as the evaluation of the function. For instance, it says yes, it's aligned right, or no, it's not aligned right, but that's not very informative. Much better if we could have some kind of numerical description of the function. You know, like the disk speed actually showing the speed with numbers. And also with radial alignment having some kind of numerical representation of the alignment. Because, I mean, yes and no, it all depends on how narrowly that they, the criteria are that they use in evaluating it. I mean, for instance, with disk speed, those that heard my presentation Thursday, remember I put a knob on the front panel of the drive for speed, and using, I think it's Apex software, you see that there's quite a range of speeds going from all the way over left all the way over right. What I've noticed though with data life speed analyzer, I can put that dial in any position that says it's good speed. So it's just not very informative. Now what the alignment is how well the read-write head is positioned in the center of a track. I was trying to find, I know that there is some description of the number of tracks per inch. Is it 48 tracks per inch and low density disk, and 72 for double density? Does anybody have a figure like that? I know it's something like 150 tracks per inch in a 3.5 inch drive. But anyway, these tracks are written as basically like concentric circles on the rotating disk. And the disk drive that wrote the disk has placed those tracks in particular places. Hopefully the playback disk drive will put its head exactly in the center of those tracks. Then we'd have good alignment of the playback drive with respect to the recording drive. But if the disk drive is out of alignment, it might be reading more to one edge or even between tracks, and that'll mean that it might not be able to read some disks. And the way that you can judge whether you've got a problem with radial alignment with any of your disk drives is if it can read and write its own written disks with no problem, but it has trouble reading others' disks, disks written on other disk drives, then it's probably some kind of alignment problem. And the alignment tester on the app test software will give a numeric value to represent this alignment factor. Okay, let me put that one into the drive. We're finished with data life, but are there any questions about data life? Okay. Okay, this is from app test. I think I've added a few other tests into it. Let's see, what is it? I hate to leave blank space on a disk, so you flip the arrow keys and you can see lots of other little diagnostics. But the one that we're going to use is B, C, and D. Now, the disk has put some instructions on here. I think my 10-page handout goes into more detail on it. We'll take a quick look through these alignment instructions that come with the software. One thing the author doesn't actually do is to tell you how to adjust the alignment. He tells all about how this software measures the alignment, whether it's accurate or in error, but he doesn't say how you make an adjustment to correct it. Yeah?
I missed when you were shifting it. Did you say what program this was?
Oh, this is called app test. APTEST, came out in 1983. Okay, so let me, let's see up. Whoa, hey, what happened there? Oops, not supposed to do that. I might need to try a different disk. Let's see, C.
Last time we tried that.
Yeah.
What happened before is you ran it down. So.
Oh.
Yeah, our test.
That's why I crashed.
Oh, okay. Oh, okay. Let's see, disk drive relative alignment. Oh, copyright 1980, so it is really, really old. What would this be, the original Apple I, or was the 2 Plus out by 1980?
Oh, yeah.
Yes.
Oh, okay. Let me do the instructions. I'll kind of scroll through his instructions, maybe make comments. Okay, it doesn't measure the absolute alignment of a drive, but it does measure relative alignment between a drive and a diskette. What it means by that is that it's always with respect to some disk that is placed in it. So the idea is you find a disk that seems to play well on everybody's disk drive. Usually these are the commercially made disks, such as the disk produced by Apple itself, all those disks that came new with the computer with the Apple labels on. I think Apple paid pretty close attention to this, and so it's good to use theirs as the standard. What I've found, though, is it's actually best to sort of test a lot of different disks and maybe take an average of several disks when making a judgment about this. There's no standard for the results presented here, but useful. Let's see. The slot and drive will be requested. The program will try to read the diskette. It'll stop and then show the results. It shows several numbers on this. The fraction right is a fraction that the data tracks were read correctly. It should always equal 1. That's the most important of the measurements. In fact, if a test shows 1 on this top number, I'm almost reluctant to fiddle around with the stepper motor in there to get better alignment. It means that it read everything correctly on all of the tracks. Let's see, then other numbers, results from trying to read between the tracks, the fraction of the times the higher track was read versus minus or minus the fraction the lower track was read. If the drive is well aligned, those two sources of data should be about equal. If the drive has a misalignment in it, it'll be reading more of the tracks, say on the lower relative to the upper, or vice versa. But what we really hope for a well-balanced, adjusted drive, that those two should be about equal. Okay, the first difference, the average of all such tries, One labeled going comes from head motion from low to high. Let's see, are the low tracks near the hub and the high tracks near the rim? I'm a little unsure about that.
Yes.
But anyway, then the one that's called coming will be in the opposite direction. So it jumps along track by track, going outward and then going inward. Let's see, different smart coming results from motion from high to low. And let's see, the results will vary a bit. If the differences are greater than 0.9 or less than 0.9, then there is a significant misalignment. And let's see, which means that the drive that initialized the disk head is not positioning its head where yours is. The alignment is different and needs to be adjusted. Let's see, this is saying, well, it's not always the case, but generally the greater this second set of numbers, the larger that they are, the more likely that it's out of alignment. Okay, so test disk for a reliable source like the Apple factory disk, and do a number of disks. If the differences are between 0.3 and 0.4, and they can be less than that, then you're doing quite well. I brought a duo disk along, and I was going to offer it at the the vendor fair, but somebody I had it listed up on eBay. The two drives in this duo disk are about as perfectly matched as any pair of drives that I've done, so that if I record the disk on, say, drive A and play it on drive B, the differences are even way below 0.3. It's almost good luck to be able to adjust it that perfectly. Let's see, if differences are much more than 0.3, and then you might be having problems. But I think it really only judges you having problems if the drive has trouble reading other disks. Most especially if it has trouble reading factory disks, then you probably have to adjust for it. But if this top number, and you'll see it on the screen real soon, if that is 1, I would almost say don't mess around with the stepper motor adjustment. Okay, if there are more problems than alignment, okay, let's see. Okay, it's back to the beginning. Anyway, let me load the software now. Oh wait, it's right back there. I'll just reboot. I've got a couple of disks here that I call alignment tester, meaning that I've tested on a variety of drives that I brought with me, and I kind of concluded these two are pretty well aligned. Okay, C. Okay. Okay, now slot number, whoops, let's see, which. 7. Drive 1. Okay. Oh, it's doing this Apple 5.25 disk. Let's see. Okay. There, see this one called the fraction right 1. That means that it read every track and read them accurately. And what this number is simply averaging between these two. This one minus 0.67 and this is plus 0.1. This average here, 0.33, remember it said it's okay if it's 0.4 or less. So this particular drive is well aligned with the disk that I just put into it. Let me repeat it with the same disk in that same drive. You'll notice that you don't get exactly the same numbers every time. Let's see, 0.33, 0.67, and 0.1. Okay, it's just gonna repeat with the same disk and the same drive. It could be that we get the same numbers, but it does vary a little bit from trial to trial. Maybe if I popped it out and then reloaded it into the drive, it just might be clamped. Yeah, look, it's very, very similar, but not exactly the same. But anyway, since the combination of those two is 0.32, this drive is well aligned with this disk. Let me try the disk 2 now. 3, slot number 1. Oh, wait. Oh, pardon me. Whoops, not slot 1. Whoops, how can I get out of this? Whoops. Okay, wait, slot 7, 1. Oh, darn, it's doing the 5.25 again. Slot 6. Okay, now it's doing the disk 2. I think this 2 is pretty well aligned, but I'll to demonstrate what I'll do is I'll misalign it and then fix the problem. I don't know, it's kind of like puncturing a tire to demonstrate fixing a flat, but all of the drives are pretty good. Oh, okay. Now the disk 2, okay, fraction right, it read every track accurately, but notice that these are outside of the range of plus and minus 0.4. Okay, it's kind of reading in the one side more often than the other side when they should be more balanced. If it's in the middle of the track, it'll be these numbers should be small. So this one suggests a misalignment in there. It's not a serious misalignment since it read every track accurately, the top number being 1. Let me put another alignment tester into it. I mean, this is one that, based on the fact that this disk played well on other drives, I conclude that it's been recorded on a pretty well-aligned disk drive. Okay, it's running through the test now, but with a different disk, but in the disk 2 drive. Okay, okay. It's still reading every track accurately, but notice that it's still showing some bias, all of these being negative, and they're outside the range of plus and minus 0.4. So it's having some problems, although it did read every track accurately. Let me try to find one. Okay, here's one that was written on yet a different drive. Okay. After this one, then I'll loosen the bolts on the bottom of the stepper motor and misalign it in order to fix it. But I imagine it looks like there's a consistent pattern. This one is too much on the negative side. Oh wait! Oh wow! This one. Oh, let's see. But these look just gray. It appears to be in the center of the track of the drive that wrote this disk. But look at this one, 0.1. It missed a lot of data on this one. So even though it seemed to be consistent with it, this is not one that I have used as a standard, though. I mean, I just kind of picked it out of a box of disks to find one that was written on a different drive. Okay. Let me put in one more to see whether there is this pattern of negative scores on those middle categories that were shown up there. I kind of think that there is. Okay, it's doing the test right now. Oh yeah, look at that. See, this is fraction right. It did read all tracks, but look how strong this bias is in the negative direction. Okay, so these test disks have all come from different computers. Does anybody happen to have a factory Apple disk in your pocket? You know, the ones with those nice labels on it. You know, like system disk or you know, that packet of disks you get with a computer when it's new. Nobody happens to have one. I didn't think to grab it either. Those would be the best ones to use as a standard. But anyway, I would say from the number of disks that we've looked at so far, this disk 2 drive is showing a bias in the negative direction. It's landing on the track a little bit too much to one side when this figure should be closer to 0. The closer this is to 0, the more balanced the reading is. You know, maybe mostly right on target, maybe a little bit there, but also a little bit there, and it would be well aligned. Okay. Okay. Well, let me ram that nail through the tire to demonstrate fixing a tire. That means loosening the stepper motor. Okay, I imagine everybody here has looked inside of the disk drives. You know, like it's, I'm sure everybody probably did this within the first year of having an Apple. Wonder what's underneath there. In the bottom, we have the drive belt, this stroboscopic pattern for adjusting disk speed. I think Tony mentioned it during his presentation that with the flashing fluorescent lights, when this thing is spinning around, these two circles with black and white patterns. One of my things for 50 hertz and the other's for 60 hertz. So if the speed is adjusted perfectly, the stroboscopic effect from the room lights will make one of those patterns appear to be stationary. Now this big thing is the stepper motor. Every drive has one. And the stepper motor is held in place by two big bolts. Let's see, I don't know. You can see one bolt is there, the other bolt is there. And the way that we adjust the track centering alignment is I loosen those bolts and then twist the stepper motor either to the left or to the right. Now the number of tracks is tremendous. Does anybody know double density disc is at 72 per inch? I somehow remember the figure 48 per inch, but I think that's for the low density disc, not double density. But anyway, those tracks are very tiny and very close together, and lots of them per inch. So when I loosen those bolts and I move that stepper motor, it's not going to be moved very far. If I even moved it even probably a 32nd of an inch, it's going to put it way off scale. So the idea is you loosen them, very, very carefully move that stepper motor, then tighten up the bolts. Another technique that I developed on my own is that you want to sort of be able to see where the bolts were positioned before you started fiddling with it. So I took a marker pen and I put some little marks there. I don't know if you can see it or not, but I put 3 little black marks there, 2 little black marks there. That's so that when I start fiddling this thing, if it gets way out of range and I'm not even sure where I began, I can look at those marks and that'll tell me where I began. So I might go back to the beginning. Okay, first thing is put it on the table here. Take the Phillips, the large Phillips. Oh, by the way, these bolts are held in place by paint. There is, again, I'm not sure if you can see it, but there's little spots of green paint on those bolts. After adjusting this thing as perfectly as possible, then it'd be good to put some more paint on those bolts so that they don't move. I didn't bring any paint. I tried it with whiteout, but whiteout I don't think has enough gummy stickiness to it to really do it. Okay, well, let's see, it was in the negative direction. It's been a long time since I did this. I'm going to just try moving this clockwise. Okay, and then I'll tighten it up, start up the software. This probably has to be repeated 5 to 10 times. Sometimes you get it pretty well adjusted, and then the next time it goes further off, but it's sort of a trial and error situation. Okay. Oh, whoops. Okay, back to C. This should only be done with 2 floppy drives because this one has got to be able to read the program in each time. If I try to do this with only 1 floppy drive, that thing might right now be so far out of alignment that it wouldn't even be able to boot the disk. Okay, slot, what was it, 7?
No, 6.
Drive 1. Oh, darn, whoops. This one is 6. It's likely to be way off because, well, let's see. Looks like it's still reading every track. Let's see, I think this last disc, these numbers were up in the 90s, weren't they? So it looks like I moved it in the correct direction. Looks like clockwise is to make the numbers go from negative to more positive, but I just didn't move it far enough. Okay, I'll turn it off and do it again. Let's see. It's a non-metal table, isn't it? I think usually when I'm doing this, I put a towel down so that the analog card doesn't get any pressure or anything on. Okay, if I moved it just a tiny bit more in the clockwise direction. Okay. Okay, I'll remember that that's in slot 6. Okay. So I moved a little bit more clockwise. The big question is, did I move it so far that I went too far? Okay, slot 6, drive 1. Okay, it's spinning. Does anybody happen to carry any liquid paint with you? Or anything like an adhesive that would be in tiny drops like super glue? Oh, hey, that's it. Look, wow. No further adjustment. Wow, that's luck. Like I say, it usually takes 5 to 10 attempts on this before you get this right. Remember, it's saying it should be below 0.4. This is 0.2 minus 0.4. The average of the two is 0.21. I can't get any better. Well, you might be thinking, well, could you keep driving down low? I suppose if you spend an hour doing this, but this is good enough. Okay, so this drive is well adjusted. Okay.
The only thing in this room that is.
Let me try with a couple of other discs to see whether we're getting rid of all of those negative numbers. Okay, I just put in a different one that I consider to be well aligned.
I think Daniel and Melissa got a whole bunch of glue sticks if you need them.
I got one in the back of the room if you want.
What now? Another drive?
It's a glue stick. No, that's not gonna do it.
Oh,
I don't think you want to.
Maybe Loctite.
Okay, now, notice that with
Mail it
this
out.
other, this is a different disk written on a different floppy drive. So of course, the numbers won't be identical to what you just saw. But even with this one, it's reading every track accurately. These two average out to 0.33. Still, it's good enough. It's still, I mean, like we conclude that it's well aligned. Let me put in,
You try to get them both within 0.4 usually when you're using it.
wait, speak up.
You try to get each of them within 0.4 when you're using a disk.
Well, I think the average figure is good enough. I mean, because this one looks like it's a little bit out of range.
Yeah.
Well, this is the one that I pay, most of all, I pay attention to this one, and then I look at this one. In the author's instructions, it's a little bit wishy-washy about this, that, use words like probably okay and stuff like
Because
that.
you could get 0.80 and 0.
What? Would I be able to get it to 0?
You could get 0.80 and 0. Would that be good? It would
Well,
average to
For your
0.40.
two readings.
oh, you mean if you had plus 0.9 and minus 0.9, this would appear to be 0 and give an illusion of being well adjusted? I suppose that would be true the way that these average numbers are combined, but they would never be that far apart. I mean, there'd have to be something really wacko about that
That's what you're testing. to see if there's
stepper
something wacko.
mechanism for it to give an extreme misalignment in going in one direction and the extreme misalignment in the opposite
Isn't
direction,
that why you're doing the
going
test?
in versus out.
That would probably be.
Okay.
Just one direction.
Let's see, okay. Whoa, the label's practically coming off that one. Now, one thing about these, there seems to be an oddity about this software. I'm not quite sure how it's to be understood, but the kind of disks that should be used to be disks have been recorded without copy protection and on a fast copier. Now, this data life disk that I played with those graphics, that had to be copied with a bit copier. It had copy protection on it. And I used, I think, Locksmith 4.1. And I've noticed this on lots of different disks, that if it's a copy protected disk, or I mean, one that's been copied with a bit copier, you never use bit copier unless there's protection that forces it. But somehow it affects the fraction right. But I just can't figure out a reason for it. I mean, the usual reason why fraction right is less than 1 would be maybe it's not reading the first track or the last track. In the printed version of the paper, it mentioned, there is an article in one of the magazines called something like track stop adjustment. Because like you get a fraction right of 0.89, that means that it's not read all of the tracks, and it's probably not reading either the first track or the last track, yet this data life software does play. But it seems to happen with anything that has been copied with a bit copier. So the standard disk that you should use for comparison would be things that were unprotected and which were done with a fast copier. But I've never been able to get 1.0 on any disk that has been copied with a bit copier. But I just can't explain the reason why that would be.
I've heard that some copy protection systems will be like a quarter of a track or a half a track off, and that's where everything except for like the boot tracks are thrown off.
I've heard that too, things like using a quarter of a track or something. And some drives can handle that. I guess it probably must mess up the disk too. It's not designed to read half tracks. Okay, so let's see, let me turn off the power on this right now. And the last step would be to tighten those two Phillips bolts in place so they don't move. Okay, so I'll use the large Phillips. Okay, I've tightened them, and then if I had the paint, liquid paint, I would put some paint around there, just like the way that they put blue, or the way that they put green paint on there. The paint is simply to prevent any radial movement of the stepper motor.
It's also to avoid the warranty in some cases.
Oh, I'm gonna avoid the warranty. I'm sure that when these things were new, you probably avoided the warranty the minute that you opened the outer case, right? I mean, I can't imagine anybody even trying to make a warranty claim. I think some other speaker, didn't he mention something like, you find these old postcards in software and stuff, maybe software is 30 years old and he sends in the postcard anyway. Okay, that's basically it. Now, if anybody has a drive upstairs that that you think might be out of alignment, I'd be happy to do it. I'm not planning to go to the movie tonight. My wife wants to see the same movie, and she would, and I would be going with her. But I'm planning to stay here. I could adjust other drives. The only thing is, I think that for me to try this, probably there should be some evidence that the drive works in other ways. Somebody mentioned that they do have a drive, but it's not reading any kind of track. Extreme misalignment could be part of the problem, but it'd be best if the drive at least can read something that could go up on the screen. Okay.
What if you have a key, what if you have a I'm thinking a 3.5 inch drive, are you using those?
Oh, a 3/4 drive?
Well,
Or you
3.5 inch,
mean one like Apple 5.25 or the Unidisc?
Apple 3.5.
Yeah, oh, it's exactly the same. There's a stepper motor under there held in by 2 bolts. You adjust them in exactly the same way. Even the half-height clones. Actually, back in my on my flagship GS, the one that I make most of the discs that I've given away, one of them is Apple 5.25, like the one up there. But the one that I also use with it is a clone called MyTap. It's a half-height clone. It's got a stepper motor in there in the same way.
What if you think you have a disc inside, but you cannot dislodge it by putting a paper clip in that hole?
Oh,
And it looks like it's either too high and bump or too low, it's bumping into something inside and can't get out.
well, yeah, if you got a disc jammed in there, actually that could probably cause misalignment because, yeah, I mean, I know you get foreign objects inside of there and you push and pull through the door, even with 3.5 inch drives, that might, the drive is not expecting that kind of movement. And if you pull something out with brute force, I can imagine.
Try with the paper clip, you know that hole you have, I think it's 3.5 inch drive, you're supposed to be able to release it by.
Yeah, the 3.5, yeah. 3.5 inch drive is very different, I think. I mean, the head of computers at my college said 3.5 inch drives can become misaligned too, but I have no idea how to adjust those. I don't think they become misaligned as much, and they do have more density of the tracks, but it's just different technology. I mean,
Work on mainly the 5.25 inch, right?
yeah, this is entirely for the 5.25.
Oh, okay.
Thanks, Steve.
Oh, yeah. Yeah, Shirley.